Thank you very much, Mary Lou, and thank you all for the opportunity to speak here today and to present some of the avocado Israeli industry. Is that okay? Do you see my screen?
We do, yes.
Okay, thank you very much. First, I'm going to present a general view of the Israeli avocado here. It's quite difficult within this frame of time to go into details, and also I will speak in general terms, so please don't catch me on a detail here and detail there, because you know they're talking about industry, but it's so much variability. But I'll anyway try to give you the picture, and I'll be happy to have questions if you have. Why is it not? Oh, few facts about Israel. I don't know if you do it on the left side of the screen. It's quite a small or even tiny country. The whole country is about 400 kilometers, maybe a little more. About half of it, the southern half, is desert. So all the farming is actually concentrated in the northern part, very narrow country, but still in this small piece, there is quite a lot of different conditions. When you go to the right side and you look at the north part of Israel, you see more or less the avocado growing areas. Most of the avocado, I would say about 85% of the avocado orchard are located along the coast of the Mediterranean, from the north part of Israel until the south. Quite similar conditions with two main changes. In the north, in the center, you have more heavy soils, clay soils, and then when you go down to the south, it's more sandy soils with much lower precipitation. In certain years, it can go down even to 0 millimeters and up to 200 maximum. And then we have two small areas in the eastern part, what we call the Jordan Valley and the Upper Galilee. It's two areas, very dry climate, very hot during the summer, actually too dry to grow Hass, and therefore if in these areas the major variety is Hass, in these areas the major varieties are Ettinger and Pinkerton, because Hass cannot actually develop in this very dry situation. The total hectares today, the total area today of the avocado orchard in Israel, actually this number is good for December 22, because right now we started to do some more plantings, but it's about 14,000 hectares, the size of the industry. As I said before, the major variety is Hass, about 60% of our orchard. It's a change from the past, because in the past Hass was about 30%, but during the last 15 years, most of the new planting are concentrated in Hass, and not because it's the best variety for the growers or give us the best results, agronomic results, but that's what the European markets want. They actually go more and more toward Hass, and so you can see that's about 60%. Another important variety for us is Ettinger, which we use as a pollinator. We need, in Israel conditions, in our dry conditions, we need a pollinizer. That was proven in my research in the past. So each Hass block must have Ettinger as a pollinizer. And also, like I told you, Pinkerton, which serves mainly the eastern part of the country because of the special climatics. Some other varieties are Reed and Galil, which cover us the two extreme sides of the season. Galil is coming very early and Reed is coming very late. So it helps us to supply avocado something like 10 months a year. That's the reason we keep them. And we also try some new varieties, especially some Hass-like variety like Lamb Hass and Gem and Maluma, and some Israeli type called Lavi, because the production with Hass, and I'll come to it soon, is it was good during the last 10, 15 years with the prices in Europe, but the way we see it for the future, it's going to be a challenge to remain on the production we have now with us, and we are looking for alternatives. Some figures about our production. So this is the last 3 seasons that we have. You see that we are running on between 100,000 tons to last season, the previous season, which was a peak season for us, with about 230,000 tons. Most of it is going for export. We are running about 60% of export. Our main market, or almost only market, is Europe. It's either Western and Eastern Europe. The domestic consumption in Israel is quite high. We have a very good local market, between 7 to 10 kilo per capita per year. Depends, of course, of the total crop and the prices in the market. But the local market is a very important part in our industry. Just to give you a small picture of the production and the hectares in Israel history. So starting 1976, we started to be commercial in avocado more or less the mid-60s. But we had good data from 76 until, let's say, last year, 2022. In red columns, you can see the hectare, the area that we had. We came to a peak of about, let's say, over 15,000 hectares during the 80s. And then we started to drop quite rapidly. The main reason was shortage of water. Israel got dry, the sources of water were a problem, and we went down to a level of about probably 5,000 hectares in Israel. And from that point, I'll soon explain why, we started to grow again and moving up to the about 14,000 tons. Look what happened to the production, average production. Again, remember that when you are talking average, it can be very, very tricky, but it can show you something. And look what happened to the production by ton per hectare. So if we ran on an average during the 70s and the 80s, we ran on average of maybe 4 tons, 5 tons per hectares. The way we are standing now is about an average. I think I have a problem with the numbers here, because something was changing when I transferred this presentation. I apologize for that, because right now I think the average that we are running is about 17, 18 tons per hectare, with quite a lot of changes during the year. But the important thing, and that will be important thing when I present you what we try to do in R&D, we cannot break this glass ceiling, I would say, of running of that. I do have to say that it's a combination of us that is running on 14 to 15 and greenskins, which are running around 20. But since, as I told you, the market is really concentrated on us, it's a big challenge for us. And we look at it as a very important task to go up with the production of the average production of our orchard, especially in Hass. What I'll try to do now is going over the different issues of the agronomy activities in the orchard, and trying to describe what is the present situation, the common practices that we use, and what is our activity in R&D, what we try to do there. First of all, starting about irrigation, some facts. As I showed you before, from the beginning of 2000, we started to grow again from something like 4,000 to 5,000 hectares to the 14,000 that we are now. And the main reason for it is that we started to use recycled water. We use sewage water, which are purified in various technologies. And it's quite amazing to see that about 95% of the avocado orchards today in Israel are irrigated with recycled water all over the country. And because recycled water are never end, because people in the cities keep on cooking and washing and do what they have to do, So the recycled water are available. We actually don't depend today on rains or freshwater sources. In terms of, I'm not going now into the details of the quality. We can discuss 2 chapters about the quality, but I can tell you that the technology today brings it to quite a good level that stands all the health and the agronomic requirements from water. What happened to us with salinity is that at the beginning of this process, let's say from 2000 to 2010, the salinity of the water was quite high. I would say even too high for avocado, between 270 to 3020 ppm of chlorides. And from that moment, it started to go down. And the reason for that is this is another, in my opinion, quite amazing detail. Most of the water that supplies today to the big cities, to the big population along the coast area in Israel is desalinated water. So we actually almost don't use fresh sources of water, not for agriculture, not for the urbanic use. And once they do desalination, they actually remove most of the salts, most of the chlorides and the sodium, which at the end of the chain affect us and give us better and better water. So at present, our, let's say during the last 5 years, our salinity is between 180 to 150 ppm of chlorides, which is reasonable when you use West Indian rootstocks. So about, I would say, maybe 95% of the rootstocks used in Israel is West Indian rootstocks, which tolerate these levels of salinity. It's not the optimal rootstocks in terms of drainage. It's not the optimal rootstock in terms of resistant to soil fungus like Phytophthora or Botryosferia or other fungus. But we are lucky enough that the soil condition in Israel are not encouraging this fungus, so we are quite okay with that. And these rootstocks can supply us the tolerance that we need for salinity. Going now into the common irrigation practices that we use in Israel. First of all, again, most of the orchards are irrigated with drip irrigation. The cause for that is, first of all, the efficiency. It can save you some water. Also, the maintenance is cheaper compared to the previous method that we used. So most of the orchards are irrigated with drip irrigation. And actually, all the orchards are monitored by sensors. And with the years, we came to the conclusion that we need a combination of soil monitoring and plant monitoring. And we use it as tensiometers and dendrometers. Probably you are aware of this tool. So we have tensiometers in the soil. Normally, we put it in two layers, 20 and 40. Sometimes we put some deeper ones, not because we expect to find a lot of roots in the deeper layer, but we want to see what happened with the water movement and to make sure we have some leaching of salts, of mainly chlorides. And the second kind of sensor that we have is based on the trunk shrinkage that represents actually the tree stress. Again, unfortunately, we cannot go too much into these issues, but I would say that probably all the orchards today in Israel are equipped with this kind of sensor. And whenever the grower is opening his computer in the morning for the first cup of coffee, first of all, he will go into this system that show him, first of all, the contraction of the trunk. And he can see 2 things. First of all, that over time, the trunk is gaining diameter, which means it's growing. And second, the contraction between the maximum diameter and the minimum diameter, which means that the peak noon and midnight are not growing. And sometimes, for example, I don't know if you can see my cursor very well, but you can see that the contraction here was quite low and the contraction here was quite big. These data can help the grower. And in addition, he can see also the tensiometers that you use in 2 depths, in 20 and 40, and by combining these two parameters, is trying to set the right amount of water and the intervals that he needs to do. This is another example of growers working on sandy soil in the south. So you see, if you go back to the previous one, these guys are irrigating once every second or even third days, while here they are working with pulses of, you can see the blue columns here, which represents the irrigation events. So it's about, they can work 3, even 4 times a day. And again, they can take a look at the stress of the tree represented by the shrinkage of the trunk and the reading of the tensiometers. And just to summarize it, you can see an example here of what happened when irrigation was not enough or was not in the right intervals. You can see that at a certain period, the trunk is not gaining diameter, which means it's stable, and the contraction is going up, which means there is some kind of problem here. And after doing some correction in irrigation, it started to climb again. The good thing about it is that these companies developed some kind of algorithm that take into consideration the data that comes from these sensors and give the grower some kind of warning. So your block is a red block or yellow block or green block. And then the grower can again in the morning go to these yellow blocks and try to see what's wrong there. This is the common practice, and actually you won't find an orchard today in Israel that is not controlled by that. We try to have as many as possible. My dream as a consultant to have 1 per block, but then the cost is coming. So I would say we have today an average of a station per 80 hectares, per 8 hectares, depends on the uniformity of the soil, and it's actually working pretty good. Coming from the common practice to the irrigation R&D that we have, I will go to the bottom line. We are not doing any more research in irrigation. During the last probably 20 years, we tried to check a lot of issues in R&D, in research project, deeper capacities, interval, the wetting area and wetting depths, timing of irrigation, in intervals, irrigation during winter. I'll have to say we had about 4 large research projects with 4 different research groups. And the bottom line was that what actually helps you is good monitoring and take a decision per orchard, per soil, per specific climate, per load of fruit. So for now, I'm not sure about the future. For now, we are not investing any more resources in irrigation. Going from there to nutrition, the common nutrition practices are the traditional one that if I'm working as an advisor for almost 40 years, it didn't change for that. As much as I know from other countries that are growing avocado, we are still applying nutrients only during the summer, the dry season for us, which is the irrigation. We are not applying any nutrients during winter. The nutrition program is based on a single leaf analysis, a leaf analysis done just before the harvest. For us in Israel, it would be something like September, beginning of October. And we use the international standards for leaf analysis. Actually, I think that it was developed in California probably 50 or 60 years ago. The levels of NPK, calcium, magnesium, zinc, iron. So we are using that, and we don't have any other parameters to use. Normally, when you look at the average that we use, we apply about 200 to 300 kilograms per hectare of nitrogen, 20 to 60 of potassium, and 0 to 100. The reason I say 0, because as I told you, we are using recycled water. In many cases, the concentration of potassium in the recycled water are very high, when I say very high, it can be something like 30, 35 to 40 ppms of potassium in the water. So it's actually, with the amount of water we supply, it's actually supply the tree all the needs for potassium. We also use on a regular basis zinc and iron as chelates with about 20 to 60 kilogram per hectare. This is the common nutrition practice. Again, during the last 20 years, we had at least 3 big projects trying to evaluate the nutrition program and the nutrition requirements of the tree. Each one of this research led to a different conclusion, sometimes extreme different conclusions. So we keep on using this. There are a lot of startups trying to suggest us other way to evaluate the level of NPK in the leaves based on the drone photography of the orchard. We try to cooperate with all these startups, but I have to tell you, for now, I still don't see any direction over there. We do have some new projects in nutrition, which are mainly they based on the work that were done before and put some light on 2 important things. First of all is application of fertilizers throughout the year, including the winter. It's actually, when you look at it from agronomical point of view, it doesn't make any sense to fertilize during winter, because we have quite a lot of rains which can leach the fertilizer. The soil temperature is low, therefore probably the efficiency is low of supplying nutrients. And even our irrigation systems are not in operation mode during most of the winter. So it's becoming difficult to supply fertilizers, because all of our nutrition is done by fertigation. But still, we have some reasons to believe, based on previous research works, that maybe, I would say, starving the tree for too long, maybe for 4 months, is not doing good for the trees. And therefore, we start to check all these ideas of winter. We are in the beginning of that. The second work that we start to do now is actually questioning whether the international or the standard norms that we have for NPK and microelements in avocado leaves, the one that I told you that we are using for the last probably 60 years, is it the correct one? Because like I told you, if you look 30, 40 years ago, we ran on average of about maybe 5-6 tons per hectare. Today, we are going to 15, 18, which I believe in the coming future, will not be enough for us. So maybe there is a need to change the standard. Maybe 2.2% of N in the leaf is not enough. Maybe you should go up. It's questions that we are trying to do now, and we are busy with that with R&D. The second issue, which we invest quite a lot, actually I say money and resources, is the issue of the plant growth regulators. Like I told you, you saw the fact that we cannot break this production, this average production of, let's say, 15, 16 tons, or for us, 14, 15 tons per hectare per year. And we think that our irrigation, I say we think because that's a common perception that we have, that we know how to irrigate more or less. We don't believe that nutrition can do big changes. We do believe that we should check it. So we are trying to manipulate the tree by using a plant growth regulator. It's quite a tricky area. By the way, the common practice today in Israel is the application of gibberellin inhibitors, mainly uniconazole, during the flowering time, in order to prevent the competition during flowering between the fruitlets, the new fruits coming, and the vegetation that we have. It's happened for us in the spring, during April, May. And this is in use in Israel for, let's say, over 30 years. And we do have a lot of evidence that shows that, that it works. And I would say that most of the growers are using it for most of the varieties, not all of them, but definitely for Hass, for Fuerte, for Pinkerton, it's definitely improved the production. We are busy trying during the last probably 10 years a lot of variations of plant growth regulators. I try to put here some kind of a drawing to show you. So first you see what happened just during the year. We have the flowering in April, May, more or less, flowering and set. Then we have the massive fruit drop, the small fruit drop happening in June, July. Our differentiation, exactly, we can't tell exactly when, but we believe it's end of October until beginning of December, depends on the year, depends on the variety. And the new thing that we are trying to do now is, I actually don't see, okay, is actually using some gibberellin. I don't know if you see here, for me it's hidden by the ruler. We're trying to use some gibberellin through the irrigation system, through soil application, based on works that were done in South America, in Peru and Chile. We tried in Israel as well to have a better balance between vegetation and productivity. We are trying to use gibberellin, gibberellic acid, prior to the flowering or the first stage of flowering, again in order to improve fruitlet retention. There is a new trial trying to use salicylic acid during the winter in order to increase flower potential in cases that we expect that there may be a problem of flowering potential, especially after on years. So we try this as well. And then there is some gibberellic acid sprays during the early differentiation period, and again in order to improve the balance between vegetation growth and flowers. This you can see it especially in years when you are coming out of a very low season. Normally the fruit reacts with a very strong flowering, and we try to balance it. So actually you see that we are trying to cover a lot of areas. We are doing it for maybe, I don't know, over 8 years. And the point with this research about PGRs, plant growth regulators, is, I would say, the biggest problem is from time to time we have a success. Because sometimes you do some kind of a treatment, you have all the theoretical background to do it, and you get a very good success, then you try to follow it the following year, and you cannot repeat it. Because the physiology of the tree is changing, the climate is changing, a lot of issues are changing, and it's still a challenge. But our approach today is that we shouldn't let it go yet. We should invest it in more. And the idea is not to develop protocols that every year will come, you will spray gibberellin, you will spray uniconazole, you will spray. This is not the issue. The issue is to supply something like a toolbox that from different situation in the orchard, after a very year or after a very low year, or if the vegetation is very strong or very weak, we shall be able to supply the grower tools that may help him put the tree into production. We know that the variability in the orchards makes it very difficult to develop a protocol, a very specific protocol. But we're still ready to go for this direction, because mostly from all our experience, using it, let's say cautiously, you can avoid damage. So as long as we don't expect any damage in terms of the situation of the tree or damage to the flowering or damage to the set, we want to have this set of tools to try to improve. Because like I told you, for us, it's a fight trying to break this average production that we have going toward the 20 tons. So we are still busy with that, and I assume that we shall keep on doing it for the coming years. About pollination, so the common practice, again, I think it is quite more or less the same in most of the avocado growing areas that I know. We're still using the traditional honeybees with the traditional hives, with a concentration of about 5 hives per hectare. Sometimes we try to go up, but it's difficult because by the way, we see all the issue of the pollination of the honeybee activity as a kind of a strategic threat to our industry. It's getting more and more difficult to grow bees in Israel because of the urbanic population expanding and the other issues. So we believe that we should go for some changes. So we do invest in R&D, trying to improve the common practice. And the first thing that we do is still using the same traditional honeybee, but in a different kind of hives. There is a big project that we are trying now to use robotic hives. You see now on the picture the structure of this hive. It's a different structure with a robot in the middle that actually moves all the time and gives you idea about the situation of your hives, the healthiness, the situation of the queens. I'm not an expert in beehives, but it gives you a lot of online information, and also the pollen and honey accumulation in the hive. And we are busy with that for 2 years. It's actually a private startup that we are working as industry with them, and we do believe that this can help us improve the traditional way. The second thing that we do try to do is improving pollination is using the bumblebee. There is a project running. I think this is the fifth years of this project. Bumblebee is allowed in Israel. It's here in the nature, so we can use it. And again, it's very interesting to see the results that we have from the research, the control research that we have are amazing. When you look at all the research that they mark trees and put the hives and look at the pollination rate and the product, it was unbelievably good results. But once we started to go out from the research into the big blocks, what we call the model blocks, which are busy for the last 2 years, unfortunately, the results didn't come back. So where we're going on a wide scale, we don't see, we still try to analyze it. We have a very good researcher, Professor Rafi Stern, dealing with this. And he also looks at the results, and it's difficult to understand. So we haven't dropped it yet, but it's definitely not a protocol for us. So we'll keep on trying it. But the way it is now, I'm not sure. And the last interesting thing that I want to show you in terms of pollination is, for me, the future. It's what we call the artificial pollination. It's systems that are doing 2 stages. First of all, harvesting of the pollen, and then I would say shooting the pollen back at the correct time onto the trees. And unfortunately, all the pictures that I can present you are not from avocado. These guys, and there are at least 2 startups dealing with this. These guys are still working now with mainly almonds and pistachios. By the way, a lot of the work is done in California. And we try to push them to go into avocados. The first, let's say, the first try that they started to do on a very small scale shows that there is potential for avocado. You actually can harvest avocado pollen. You can probably preserve it. With the almonds, they store the pollen for 1 year. I'm not sure it's going to be the case in avocado, but for me, for the future, this is something that we should all look for. The problem is that the cost or the money you have to invest in this kind of systems is much, much bigger compared to what we are used to in normal R&D projects in agriculture. Over there, we are talking about maybe $100,000, $200,000, $100,000. Here they speak about $1 million. So as an industry, it's difficult to start with it, and we are all the time looking for ways how to go on with it. But for me, this is a real interesting direction to go for the future. A little bit to speak fast about issues of planting distances, pruning, orchard design. The common practices today in planting in Israel is 6x3 or 6x4. We went for a more short distances in order to control the height of the trees. About 10, 15 years ago, we also started, like many other parts of the world, to go into a very, very high density orchards, like maybe 4x2, 5x2.5. For us, it was a failure, mainly for the reason that it requires a lot of manual labor. And with the cost of labor in Israel, it makes it impossible. So we dropped it, and these are the planting spaces. About pruning protocol, I told you that there are none, but it's actually not true, because let's say that if you can find in Israel 400 growers and about 10 advisors, there are probably 4,000 protocols for pruning. So each advisor with each grower will do something, and you cannot really put the finger on a specific protocol. There are two main principles that there is no argument about it. First of all, avocado need lights, optimal light penetration to all parts of the tree, including the center of the tree, including the intervolume of the tree. At least there is no doubt about that. And the second important principle is the need for constant rejuvenation of the tree. It's different with the varieties. The biggest, the more important variety in this issue is the Hass variety, and it's crucial for us. So as I told you, we are not doing any R&D in pruning today. We don't think it's makes sense to do it. As long as people know that they should keep these two principles. Just to show you, I couldn't resist it, so I told you there are 4,000. This is probably one of my favorite ways of pruning protocol, that you take the orchard, divide it, and every year you prune every second row. So this is the row that was pruned this year. This row was not pruned, and we expect most of the production. We are running with this method for about 6 years, and it's working nicely. It's a very schematic system. As you can see, we need to mechanize most of our pruning activity, again, because of the activity. And again, just to show you how important is the rejuvenation, we learned all over the time that you should never, actually people say you can never prune avocado too strong. So don't be afraid to remove strong limbs in order to rejuvenate the tree, to develop new limbs. So in a way, your tree can be 20, 25, but your older limb will be maybe 4 to 5 years old, which has a lot of importance. Going from here, and I'm trying to come to the end of my too long presentation, talking about post-harvest issue. So post-harvest is not in the level of the orchard. Even today, we realize that in order to get good quality of the fruit and longer storage period, you need to go back to the orchard. We are still not there, but we start to look at factories in the orchard. Today, the common practice today that we have in post-harvest is the traditional one that we use. Like I told you, our main destination is Western East Europe. Between 2 to 3 weeks shipment time or storage time from packing to the customer. And the means that we are using are the traditional one that we are using for the last maybe 20 years. It's cooling conditions, it's modified atmospheres, conditions in the container. and the use of 1-MCP, which helps us a lot. The point is that we cannot use 1-MCP on Hass variety because most of our clients in Europe are selling the fruit as ready to eat, and the 1-MCP is not good for this procedure, for the ripening, so they don't allow us to use the 1-MCP. So, but we do use it for the green skin. So this is the common practice that we use. The post-harvest that we are doing in R&D, we are trying to change a lot of factors. First of all, we are looking at different targets. If I told you up till now that our present target is almost 100% Europe, Europe is getting very crowded with a lot of new players coming into the market there. So we are, even though our window, the winter window, is still good in Europe, it's also become more and more crowded. So we are looking to the east, mainly Japan, China, India, which for us mean going from the 2-3 weeks to 6 to 7 weeks. So we need different ideas. What we use now is a graduate change of the temperature regimes, what we call climatization. I'm not sure that's the right word in English, but that's what we use during the shipment time. Also adjustment of the modified atmospheric conditions, so not using the same formula for the whole period, but change the formula over time. And like I told you, the most important thing which we invest a lot in the recent 2 years is the issue of managing the harvest according to dry matter contact. This actually caused us a big change. And if I take you again to some of the figures that we have, first of all, we found that the accumulation of dry matter over the season is quite linear, and it behaves quite more or less the same in different seasons, even though you can see that in one season, in week 1, which is the beginning of January, the average was 30, and in another season, the average was 28. But the important thing that when you start the season, you can already predict more or less what's going to be the dry matter content at the end, or the middle, or at the end of the season. And by knowing that, you can adjust your harvesting program. So today, we try to sample not all, but as many as possible of blocks, different blocks. And actually, the growers can have, this is a grower with 4 blocks, and you can see the accumulation. And there are some interesting, because, for example, you can see that if you look at this block, which B1, the green one, it started at the beginning of the season with quite low dry matter, but then the rate of accumulation was faster. So by this data, you can try to take decision which blocks to harvest early and which blocks to leave to the end of the season. And I have to say that it made a big change for us in terms of qualities issues. Again, you can see that in different seasons, you can move. What happened to us that we started to study and looked at in the last season, we actually moved the whole curve of the harvest much earlier in order to avoid quality issues. And we still study it, but we believe that for us, this is a very important. Now, I just mentioned dry matter, but there are probably a lot of other factors in the orchard, like nutrition, level of nitrogen, calcium, a lot of other factors, which in avocado, we never really thought about it in the future. I know that if you take apples, for example, for them, the level of calcium and nitrogen in the fruit and the relation between them is crucial for the quality of the fruit. At least in Israel, in avocado, we never pay too much attention for that. Now we realize that we need to start do it and to use the data from the orchard. That's it, more or less, what I try to present. And I hope you got the picture.
Thank you, Udi. That was great. We have a lot of questions that appeared, and when we have the open discussion, you'll be very busy answering questions, I think.
Here.